Hello everyone. In today's lecture, we have to discuss the some more basic concept of that transient state stability. In terms of the transient state stability, that we all know it is nothing but the ability of that system to retain the synchronization even of the large disturbances are generally occurred for the long period. This is nothing but what the disturbances, the duration of that disturbances should be nothing but the higher as compared to the steady state stability, steady state instability. Okay, so in terms of the transient one, the duration of that fault should be nothing but the more one as compared to the steady state. The system that suffers from that sudden change of or the large disturbance in that condition, it should be is nothing but the transient stability limit. That is nothing but the maximum power that transfer without the system becoming unstable. Means what? The system that suffers to be the longer duration, with like the sudden change of the fault or the sudden excitation increase or the decrease one, or even is nothing but the some unsymmetrical or the symmetrical fault duration. In that case, the system should suffer the more transient or the abnormal behavior in the transmission line. Means what? We are not getting the exact power from the as compared to the generation side. Means what? If the generation is should be carried out at a 5000 megawatt or the 500 megawatt, we are not able to get the 500 megawatt at the receiving end. So because of the disturbances of the transient generally occurred for the longer duration. So in that case, the transient stability limit is not even what? It's not even the maximum power that can be transferred without the system should becoming the unstable. Means what? Become because without affecting the system, without affecting the system should be the unstable. Unstable is that important where that because of the unsynchronization without affecting the their synchronization, the system should that call as is that important transient state stability limit. So from the above graph, we are able to understand that the fault current and as compared to the steady state, it should is not about a constant word. It's not about the small and the gradual changes in the fault current is generally occurred with respect to the time. That's called as steady state. Okay, whereas steady state stability limit, the steady state instability limit is study but what it should be for the longer duration, short duration, and the small gradual changes are generally occurred as compared to the transient one. Whereas we observed in terms of the transient one, the fault current should be the rises one, and as the study but the abnormality is showing more as compared to the steady state. Even in the sub transient, the abnormality is more as compared to the transient and the steady state. Okay, so the transient state analysis is nothing but the ability to retain their synchronization even after the abnormality or the disturbances occur for the longer period. That's called as transient state analysis. So what is the factor affecting the transient state analysis? Number one, the higher system voltage level. If the system voltage level should be the higher, even the load should be the more fluctuating, then the transient state stability should be the more affected. Now, how can we improve the steady state stability? Number one, एक तो steady state stability improve करोगे तो automatically transient state stability automatically improve हो जाएगा. So what are the different methods to improve the steady state stability? Number one, higher voltage level. If you have to maintain the voltage level should be the higher one, then it's not but we are able to understand that the steady state stability should be improved. If the steady state stability should be improved, automatically the transient state stability should be if effectively improved. Number second, so what is the additional transmission line? Transmission line, if you are able to understand that the transmission line should be the more one, means what? Additional transmission line means what? The one of the bypass transmission line should be the there, so that we are able to improve the steady state stability. Means what? If there is a fault should be the occur on the one of the transmission line, the another transmission line should be the comes in the picture, so that we are able to improve the steady state stability. Number third, smaller transmission line series reactance. The series reactance जितना reactance कम रहेगा उतना steady state stability improve होगी, stability improve automatically. We are not able to getting that transient transient reactance. Okay, smaller reactance, series reactance कब लगेगा on smaller transfer leakage reactance. As we are studying about the additional transmission line or the voltage level should be the higher, the leakage reactance of that transmission line should be less as possible. Number third, series capacitive transmission line compensation. And that by connecting the series capacitive transmission line, we are able to increase the voltage injecting the higher voltage. Injecting the higher voltage, automatically you are lower down the reactance of the transmission line. Reactance कम किया, automatically उसका stability limit improve हुआ. Okay. Otherwise, add some compensative network in the compensator in the flexible line network in the transmission line, like the flag devices बोलो या फिर static bar बोलो, one compensator should be connected in the transmission line so that to improve the steady state, or else to improve the transient state stability. Okay. Number second, higher speed fault clearing. जितना जल्दी fault clear होगा उतना that longer duration of the fault duration or the fault instability condition should be the less as possible. Instability condition less रहेगा तो automatically synchronization affect नहीं होगा. Number third, high speed recloser of that breaker. Means what? Fault clearing time is should be the high. Means what? Less fault clearing time. Jitna high fault clearing high speed fault clearing is nothing but we can say that it's nothing but the high fault clearing, less fault clearing time. Clearing time कितना लगना चाहिए? कम से कम लगना है. So that high speed recloser of that breaker should be there, so that it should break the reclose that circuit as soon as possible. Number third, single pole switching. Single pole switching is taking the less time as compared to the multi-pole switching. Number four, large machine inertia or the lower transient reactance. In that case, we are able to getting that more. It should directly affect the transient state stability. Third, high gain exciter. High gain exciter रहेगा तो automatically transient stability affect होगी. Now, fourth, braking resistance. Braking resistance. So this is not even all the parameter on which the transient state stability are generally dependent. Okay. So how can we improve the transient state stability? By lower down the clearing time, fault clearing time. Single pole switching use किया, मशीन इनर्शिया उसका लेस रखा, लोअर ट्रांसिएंट रिएक्टेंस रखा, जितना कम रहेगा उतना ट्रांसिएंट स्टेबिलिटी ज्यादा रहेगी. ओके, सो दिस इज ऑल अबाउट द फैक्टर अफेक्टिंग द ट्रांसिएंट स्टेट स्टेबिलिटी. So in terms of the transient state stability, we are able to again revise the previous all the basic concept, just summarize in the following points. Number one, the transient stability is what? Its ability to retain or to remain in the stable condition. Stable bolo या फिर synchronization bolo under the large disturbances or for the long disturbances or for the large disturbances for the longer period, like the short circuit generation or the load losses or the excitation losses. That is all about the transient stability. The evaluation of the transient stability are generally defined required for the offline system also and for the online system also. Offline system में आएगा एक तो planning, second designing, and for the online, for the load management, emergency controlling, and the security assessment, online load dispatchment, offline load dispatchment. This all the parameters that is ready, but the controlling of that power system is play the very important role to evaluate the transient instability. Okay, so this is nothing but the ALDC, ABC, AVR, and the ALFC that play the very important role in terms of the evaluation of that transient stability. Okay, number third, the transient stability generally deals with what? Actual solution of what? Non-linear differential equation. Non-linear differential equation because it's nothing but a transient behavior है. किसका transient behavior है? Transmission line का transient behavior. और उसके हिसाब से उसका non-linear differential equation आएगा. So that describing the dynamics of that machine with respect to their inertia, with respect to their load angle, with respect to their study, but the torque, mechanical torque and the electrical torque of that system, and interfacing with the algebraic equation describing the interconnection with the transmission network. Okay, so the disturbance, as we all know, as the disturbance is large, the linearized equation of that single equation is not possible, because the we will discuss that single equation in the next lecture. But the swing equation is nothing but what? It just defining the relation between the mechanical load with respect to the generating load. That is nothing but the electrical torque that should be the balance with the mechanical torque with respect to the swing equation. Okay, so the as we all the structural changes in the network, the power angle prior to the fault, during the fault, and the post fault may be the different. Fault that are occurred with respect to the transmission line, where prior to the fault or during the fault or the post fault situation are generally affect the transmission line. So due to this reason, the general stability criteria for the transmission line cannot be established. So as we done in the case of the steady state, it should be the study but the more than zero. That is the steady state value. The SPC should be study but what? It should be the more than zero. So the transient stability behavior is study but the more transient we are getting for the longer duration as compared to the steady state. Okay, so there's the ability to establish for the given fault by the actual solution of that swing equation, and the time taken by the fault should be the clear is called as clearing time. Means what? That clearing time, and the in detail we will discuss in the next lecture, but here we have to understand that what is the difference clearing time? The time taken by that fault to clear itself or to reclose their original position, that's called as clearing time by the circuit breaker. That should be the less as possible to overcome the transient instability. If the fault should be the clear fast enough, then there is a possibility that system should again remain in the stable after the clearance of the mover. If the fault persists, like the instability or is increase, instability increase होगा तो synchronization effect होगा. Synchronization effect हुआ तो system or the load side apparatus should be directly affected. Thus, the critical clearing time is what? It's even the maximum time taken by the available fault the clearing the fault before the system loses the stability. Means what? Critical clearing time. It's a even what? It's a TC. It's a time taken. It's a maximum time available fall clearing the fault before the system loses its stability. Means what? Loses its synchronization. That case is called as critical clearing time. Okay. Number 4, modern circuit breakers generally equipped with a auto recloser facility, whereas breaker automatically reclose after the two sequential openings. Okay, so the modern circuit breakers are what? Generally the auto reclosing facilities are there, whereas the clearing time should be the less as possible and should becomes in the system should becomes under the stable condition for the longer duration of that time. If the fault is still there in the circuit, it breaken the open permanent. The breaker should open their contact permanently. Okay, since the most fault are the transient one, first reclosing is nothing but the in general successful, hence the transient has a greatly enhanced by the auto recloser breaker. So auto reclosing breakers is play the very important role to overcome the transient instability, to lose their in synchronization. The auto reclosing breakers are play the very useful in the normal cases. Okay, what are some general common assumption are made during the transient stability? Number 1, the transmission line and the synchronous machine resistance should be the neglected while calculating the transient instability limit. As we all know, the resistance introduced during damping is the swing equation give the permissible result. Number second, damper winding effect should be the neglected. Third, variation in the rotor angle or the rotor speed should be the neglected. It should be the assumed to be the constant. Means what? The rotor speed is assumed to be the synchronous and it's assumed to be the constant while calculating or while analyzing the transient state stability. Number 4, the mechanical input of that generator is assumed to be the constant. Mechanical input constant रहेगा तो automatically that electrical output we are getting is nothing but a constant one. This lead to the governor control loop is should be the neglected. Okay. Number 5th, the generator model is to be assumed to be studied but a constant voltage source behind the transient reactor, neglecting the voltage regulation action. Voltage regulation action should be the neglected. We are getting the study but the generator should be getting the constant voltage. Number 5, 6, the load is modeled as a constant. Load कितना है? Constant as assumed to be the burst admittance matrix. Number 7, the shunt capacitance is not difficult to account for the stability limit. Where ignored, no greatly significant error is occur. So this is all is nothing but a parameter or the assumption we have to make while analyzing the transient stability. That as we all know, the study of the transient stability of the single synchronous motor infinite bus system, one led to the some important aspect of that stability of the larger system. Means what? Single pole, that is synchronous motor infinite bus में एक अपन particular area अपने analyze किया, and that area should be, that result should be over, should be applied to the whole system. That's called as stability for the larger system, and that is one of the important method for that, studying the transient state stability of the synchronous motor infinite bus is nothing but what? It's a equal area criteria. Means what? The electrical power and the mechanical power we are analyze, we have to uh, overcome, or we have to equate with each other, so that the we are not able, we are not we are analyzing the transient stability with respect to the equal area criteria. Okay, so in next lecture we will discuss the equal area criteria concept, that is a very important to analyze the transient stress stability. Okay, thank you so much.